Good morning, everybody. Thank you for coming to this session, and welcome to the last day of Build 2013. My name is Peter Torr. I'm a program manager at Microsoft, and this morning I'll be talking to you about networking on Windows Phone. Now, it used to be a few years ago, we'd start these types of sessions by telling you that all the top apps use networking, and all the best-rated apps use networking. But we figured it's 2013 now. Everybody's kind of in on the cloud. We don't really need to tell you why you need to care about networking. So we're just going to tell you how to do it. So I'm going to talk about 4 basic things today. Basic HTTP and REST, sockets, proximity, which is how devices that are close by to each other can talk to each other, and then some tips and tricks from some of the apps that we've built and some of the apps that our ISV's partners have built. But before I get on to those 4 things, there are a couple of other points I want to briefly touch on. And the first one is about choosing the right API for the apps that you're building. So if we look at the Windows Phone 8 platform, we know that people bring apps from a lot of different places onto the phone. So how many people have Windows Phone 7.x or Silverlight apps that they've written? OK, some of you. OK, so you probably use things like HTTP Web Request or maybe WCF or some of these other APIs. Now, how many people have desktop.NET apps that they might want to bring to the phone? Anybody? A couple of people? OK, and you're probably using approximately the same set of APIs. Now, do we have anyone in the audience doing native code that they might want to bring to the phone? Yeah, some people there. So you might be using WinSock maybe, or IXML HTTP request, which are some of the native APIs that we have. And then finally, I hope all of you have built Windows 8 apps or are planning on building Windows 8 apps. And so you might be using HTTP client, or you might be using the new WinRT sockets. And so the good news is all of these APIs are supported on Windows Phone 8, because we want the investment that you've made in your code to pay off, and that you can keep writing those apps and keep selling those apps on Windows Phone 8. But what we hear from developers that are new to the platform, or that the developers are starting new code, is that they don't want all these different choices. They really want Microsoft to tell them, what's the one API I should use? Right? Don't tell me 3 and say, pick one. They want to know what the right one to do is. And so what we're basically saying, moving forwards, is that if you're writing .NET code and you want to do HTTP, you should use the .NET HTTP client. And if you're doing sockets, you should use WinRT sockets. And if you're doing native code, you should use IXML HTTP request, or you should use WinRT sockets. Right. All the other APIs exist, but these are the ones that we recommend you use going forwards. So that was the first kind of minor point I wanted to make. The second one was around setting up your development machine. Now, if you've done Windows Phone 7 development before, or you've done Windows 8 development before, and you're talking to services running on your own machine, you're probably used to just using localhost as the name of the server, and everything just works. That doesn't work on Windows Phone 8, because a Windows Phone 8 emulator is actually another Hyper-V virtual machine, and so when it tries to talk to localhost, it's talking to itself. And so instead of using localhost, you have to use the IP address of the machine. And this takes a little bit of setup. Now, I'm going to go through the 4 steps that you need to do, and I'm going to go through pretty quickly, because you should be able to get this slide deck within 24 hours after this talk and copy and paste the command lines from there. I don't expect you to try and copy the command lines that I'm going to show you. But the first step to getting networking to work on the Windows 8 emulator is to get your IP address, right? And probably most people know you can type in ipconfig, and you get the IP address. Don't get the IP address of the emulator's own loopback adapter. That won't work. But pick your Wi-Fi adapter or your Ethernet adapter. So once you've got that IP address, the next thing you do is you go into the IIS Express config file, find the existing binding statement that points to localhost, and copy that, and then update localhost to be the IP address that you got from ipconfig and the same port number that IIS Express is listening on. So the third step is that you then have to allow IIS Express to run and listen on that port. Now, you can do that by running Visual Studio as an administrator. But if you don't want or you can't run Visual Studio as an administrator, you run this netsh command, plug in your IP address and your port number, and now IIS Express can listen. And then lastly, another security measure is you have to open up the firewall. So you could do this via the UI, the Windows Firewall Advanced UI, but if you're good on the command line, this is an easier way to do it. Just plug in your local port number, and everything is good. Right. So you'll be able to copy and paste this text later on. It's also on MSDN if you look how to use IIS Express with Windows Phone 8. But I just wanted to mention it because if you just try and start writing code against localhost, it's not going to work. So that said, let's talk a bit about HTTP. As I said before, the API we recommend you use if you're doing managed code is HTTP client. Now, this is a simple, modern, async, awaitable API. It's shipped in the box with Windows 8 and in Windows 8.1. And it's now available as a NuGet package to download for Windows Phone 7.5 and 8 and some other .NET platforms. And in addition to being this great, simple to use API, it has a really cool kind of pipelining feature that lets you plug into different layers of the stack, both on the client and on the server. And I'll show you a little bit of that in one of the demos. Now, if you're doing native code, IXML HTTP request is the only stack available to you if you're doing HTTP. This is a mature COM API. It's been around for quite a while. And it's built into Windows and Windows Phone. So native code, you use IXML HTTP request too. So I want to start and just do a brief demo of some of these APIs. OK, so here we are. And the very first thing I want to show you, if you just want to display a web page, right? You don't need to do anything smart or complex, just display a web page. You can always use the web browser control. So here we have in my XAML web browser control source equals buildwindows.com. So if I go ahead and run this on the emulator, it will launch, and it should go to build Windows. And so here we are in build Windows. I can click around. Because I have a touch laptop, I can do multi-touch on the laptop, and it works on the emulator, so that's kind of cool. But I told you I'd tell you about APIs. So up here, I have a link to Wikipedia, and if I click Go, it's going to go ahead and download some content from Wikipedia. So let's see how we did that. If we switch back to Visual Studio and view the code, we'll see that initially, I'm just going to use the web browser to navigate. And if I look at the web browser, all it's doing is calling webbrowsercontrol.navigate URI. So if you just need to display web pages, it's really, really simple. You can do it statically in XAML, or you can navigate using the Navigate API. But let's say that you want to do something else, and you don't just want to display the site as it appears. Let's say you need to do some processing on that HTML. For example, maybe I think that Wikipedia looks a little bit too boring for me. So I'm going to use this HTTP client. We'll run the code again. We'll see what it does, and then I'll show you the code. So here we are again. It went to build. If I click Go, it's going to go ahead and download Wikipedia. And you see now, it looks a little bit more friendly. Right? Now we've got some nice orange-colored Comic Sans MS in there. So it looks a bit nicer for me. How did I do that? Well, if we go back to our code and look at what we do with HTTP client, this is what I mean by saying it's a nice, easy-to-use, simple asynchronous API. The first step is we create a new HTTP client. You might be wondering how you get HTTP client in a Windows Phone app. I'll show you in a second. So you create the HTTP client, await the response from the server of getting that URI, get the HTML content out of that response. Then I pass the HTML to my awesomify method, which is the thing that makes it go orange. And then I just navigate the browser control to that string. Right? So really, really easy. Create the client, get it, get the response, and you're done. And so what does awesomify do? Well, first thing is it just goes ahead and injects some CSS into the body. So this is how I turn all the text into orange Comic Sans MS. So that's the silly part of the demo. But the important part of this demo, and something that you should remember, is that if you're going to do this, if you're going to take HTML and inject it directly into the browser, you need to remove meta tags. Because if you don't remove the meta tags, what you'll end up seeing is actually just the raw HTML. It won't display the formatted HTML, it'll display the raw source. So that's the important step about this awesomifying. Now, I told you I'd tell you how to get HTTP client into a Windows Phone app. That's really easy. If you right-click on the project and you manage NuGet packages, this menu option here, you will see that I have installed Microsoft HTTP client libraries. And that will automatically install the other two that you see here. And to get that, you just go online, type in HTTP client, and there it is, the first thing in the list. So you hit install, and now you've got HTTP client, inside your app, just like you would on Windows 8. So that's the basic managed API. So let's go ahead and look at native API. If I run the code, it'll do exactly the same thing, go out to the web, turn the text orange. But I'm going to actually debug this one just to show you what's happening. So I'm going to F5 this. I'm now using the native code here. I will run the app, click on Go. And this, I just wanted to show you this because this is the native code that's going to be used. I won't walk through this, and I didn't even write this native code. I just took this straight out of one of the SDK samples. Life's too short to write native networking code for me. But you can see here, it's using IXML HTTP request 2. It's calling co-create instance. It does a bunch of stuff. If you've already written native networking code, you know what this does. I'm going to go ahead and run it. Eventually, I'll get back my string, which looks like a bunch of HTML. And then I'm just going to go ahead and set it inside the control. So that's simple managed networking and simple native networking. Now I want to show you a bit more about that HTTP client API and how easy it is to use both on the client and on the server. So we will stop debugging this for the time being and move to a different demo. And so in this demo, what I'm going to show is I have here an app that's showing a bunch of different phones. Nokia Lumia, HTC 8X, et cetera, et cetera. And these phones are coming from a website that I'm running locally on the machine. And I can do things like I can click inside of them. I can create new ones. So let's say we want a Samsung Ativ Neo, I think is the name of the new one. Let's say it's purple. I don't think you can buy purple, but that just says purple. And so it's added Samsung Ativ there. So very basic kind of list-based UI. And if we look at the code for what's happening here, it's actually very, 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 very simple. If I want to get all of the phones in that list, so when I first start the app and I display all the phones in the list, again, I'm going to use this HTTP client and call getAsync with the server URL and the text phones. I'm going to await reading it as a list of phones, and then I'm just going to return those phones. Right? So super, super easy. Kind of like WCF, you've got this rich object model around simple REST-based APIs. Getting a single phone is the same way. I just make a request, read the response as a phone, and then return the results, and so on and so forth. So the client code for this is really, really easy. And the server code as well is really, really easy. If we look at the phone's controller, and this is the code that's running on the server in ASP.NET, when I create my web service, I just go ahead and I add a bunch of these static phones. These are the phones that you saw earlier. So in the list, the Nokia, the HTC, et cetera. Obviously, in a real app, you might use a database or you might use something else. But look how easy the APIs are. To get all the phones, I just return that collection or that list. That's all I had to do, right? To get a single phone, to get a phone that was queried by manufacturer, I just do a simple link query. Right? This is incredibly simple code, and it's using the same API and the same methodology of creating responses and sending responses on the client and on the server. And that lets you do some really powerful things that I'll show you next. So I have this code running on the server. I have the code running on the client. And let's say I need to debug something. But the production server is live, and I can't go ahead and just insert dummy data onto the production server or do other wacky things like that. And I don't really want to touch much of my client code. I want to keep it as close to the shipping product as possible. But what I can do is, inside my client, when I am creating my HTTP client, what I'm going to do is I'm going to pass it an HTTP handler that will inject itself into the pipeline. And then instead of going to the website, it'll actually create that response inside this application and return it automatically. So I'm going to say new demo HTTP message handler, which I happen to have written earlier on. And if we look at what this particular class does, in my particular case, I need to debug a case where there are kittens involved. So I have a bool called show kittens, which I've set to true elsewhere. And what you see here is when I get called to send async, so when my HTTP client is asked to send something to the server, I check if I'm not showing kittens or I'm not doing a particular set of APIs, then I'm going to return the base. And so that is going to go off to the website, talk to the web server, get back the real data. But if I am showing kittens, then I am actually getting the first item in the list. Then what I can do is I can new up a new phone, right, the object that I'm returning back to this list. I can actually create an HTTP response message, insert that object as JSON, set the content type, and just return that. And so now what happens is when I run this code inside the phone, and here it says Nokia Lumia 920. When I click on it, it gives me that code I set inside the client. So now it says it's a orange tabby called Mr. Smiggins. So it's a great way that you can do mocking and so forth on the client, and the same thing works on the server as well. You can mock the client from the server. So it's a great way of doing this kind of testing. And if I update this, of course, this now becomes the value of that item. Now, the really cool thing about this is I've been showing you a Windows Phone app, but if I go ahead and run this Windows app I have, it's actually using the same code to talk to the same server. So you see here it has the Mr. Smiggins that I just created. If I go ahead and add a new one, let's say we want to add the Acme Awesome 2000, which is pink, and go ahead and create that. And then I switch back to my phone and refresh. We see here the Acme Awesome 2000 in pink. And it's doing all of that through a portable class library. So this is exactly the same client code running on the phone and on the desktop. And essentially, the same set of APIs running on the server as well. So that's kind of the power of the .NET platform that they were talking about at the keynote yesterday. Now, to do this inside a Windows Phone app or a portable class library, again, you right-click here, manage NuGet packages, and you want the Microsoft ASP.NET Web Client libraries. But the important thing for this one is it's pre-release. So when you're searching for the things to add to your project, you have to go ahead and click this Include Pre-Release item here. That will give you the version of the HTTP Web API client that works on Windows and Windows Phone inside portable libraries. OK, so that was a quick look at some of the HTTP libraries that you can use on Windows Phone and Windows. So let's get back to here. So the next section is going to be on sockets and proximity APIs. Now, WinRT sockets is, again, simple, modern, async-based API. This one's shipped in Windows and Windows Phone, so there's no need to get a NuGet package for this one. It's in the box, the same API. On Windows Phone, we support stream sockets for TCP and datagram sockets for UDP. The phone does not support web sockets, whereas Windows does. And we support both client and server scenarios. So you can listen on a socket, you can open a socket, you can do all those kind of things. And then I'm going to do a quick demo here of stream sockets, and I'll have a more interesting demo of stream sockets a little bit later in the proximity section of the talk. So if we go back to our simple web browser demo and switch to using sockets, and let's switch to, let's run this. Same thing's going to happen. I'm going to go to the build website. I'm going to type in that I want to go to Wikipedia. I'm going to hit go, and Wikipedia should show up. If we're lucky, there we go. Wikipedia showed up. And this time, I'm using sockets. And if we look at what this one does, excuse me. This one is very simple. If you're used to WinSock API, this is much, much simpler than WinSock. I create a socket. I create a writer to write to that socket. I create a reader to read from that socket. I connect to that host name, so wikipedia.org on port 80. And then I'm implementing the world's simplest web browser here. I'm going to send the HTTP GET command. Then I'm going to read about 300,000 bytes. You shouldn't do this in a real app, of course. I'm doing this because it makes for easier demos, and I know that that page is shorter than 300,000 bytes. So I'm going to load them from the reader. I'm going to look for the 2 blank lines, which separate the HTTP headers from the HTTP content. And then I'm just going to send that HTML to the same Awesomify and navigate to it. Right. So really, really simple to do sockets as well. You create the socket, you connect somewhere, and then you start reading and writing from it. So really, really easy to do sockets-based programming if that's what you want to do. So the next thing you can do with sockets, which is really cool, is proximity. And this is an abstraction over several different technologies. Bluetooth, NFC, Wi-Fi. Abstracts away all of the complexity of those protocols and lets 2 devices talk to each other seamlessly over a socket. Now this, again, just like sockets, is built into Windows Phone and Windows. Same API, no need to download anything from NuGet. Some of the scenarios this does are things like peer-to-peer gaming or file transfers and so on and so forth. NFC as a specific technology has other uses. You can read and write tags, for example. In some countries, you can pay for goods and services with it. Sean McKenna, who's sitting in the back, will talk a little bit about this in his talk later on. But we're not going to look at those NFC-specific scenarios. We're just going to talk about proximity in general. And once you've connected with the proximity APIs, they use the stream socket for communication. So just like I showed you, simple reading and writing of bytes is all you need to do to talk across 2 devices. So the first demo I want to do here is actually a demo of an application from Nokia, just to kind of show you what people have done in the store with proximity. And Cinematograph is a cool app that lets you take essentially animated GIFs, and then you can share them with people and so on and so forth. So let me see if I can do this. I'm juggling different phones here. Let's go ahead to Cinematograph. And this is Sean's phone. Thank you, Sean, for letting me borrow it. And you can see here it says it's lonely in here. He hasn't got any cinemagraphs in his phone, right? He's very sad. But I happen to have one on my phone. So I'm going to switch over to my device now. And I should have Cinematograph. And I have one here of Thomas Fennell, who is our push notifications and toast notifications program manager. And he's doing his happy dance because he's finished his talk. And I want to send this to Sean so Sean can also experience Tom's happy dance. So I click on the menu and I say share. And of course, they have things like social media and email and so on. But they also have this tap and send option. So I click tap and send. And it tells me, hey, go tap someone else's phone to give them the content. So let's switch back to Sean's phone. That's very sad because it doesn't have any cinemagraphs. And Sean might just be at his start menu. I tap the 2 phones together, and it says, someone wants to use Cinematograph. So I say open app. It goes ahead, creates a connection with the phone. I might have gone too far away there. Let's try that again. OK, so it's sharing, 10%, 12%, etc. It's going to just copy that data across using that socket. And of course, I can walk away now up to about 100 meters, because this is using Bluetooth to actually do the communication. And once it's shared, we'll be able to see Tom Fennell doing his happy dance on Sean's phone too. So there he is. And it's the happy dance. OK, so that's what Nokia has done with tap and send in NFC. And so I want to show you a little bit about how to do that and show you some code that you can use to do these kind of things. But before I get to that, let's go back to the slides for a second, because I want to talk about 2 different ways that you can kind of do proximity on Windows and on Windows Phone. And I'm going to talk about the 2 participants in this negotiation as being the host and the client. They're not really technical terms. They're just terms I'm using to make this slide easier and one of the demos easier. But you can imagine as the host is someone who has content to share, and the client is someone that doesn't have the content. So the host wants to start sharing content, or playing a game, or doing something else like that. And they have two options. The first option is that they can browse for peers, right? They can look for people around you. This is similar to if you're playing a multiplayer game, for example. You go into the lobby and it tells you the people that want to play, etc. It can do that, or it can do a tap and play experience. And what Nokia did is they did like a tap and play kind of experience where one phone taps another phone, magic happens, and we'll talk about the magic, and out pops a connected socket. You don't really do any work, you just get this connected socket at the other end. And in a browse scenario, what you do is you look for peers, and you kind of continuously do that, polling to see if anybody's around. Once you've found somebody you want to talk to, you connect to them, and then you've got a connected stream socket. So they're the two kind of ways that the host can initiate a proximity-based negotiation. On the client, it's pretty similar. There might be a browsing or a tap-to-play scenario. Tap-to-play, the app gets launched, and it gets told that it's launched to handle a tap. The same magic happens, the magic that happened on the host, and magically out pops a connected socket. Or if it's in more of a browse lobby type scenario, it sits there waiting for peers. When a peer says it wants to connect, it says, hey, OK, go ahead, connect to that peer. And now you've got a connected stream socket. So they're the two kind of ways that you can do connect two devices through proximity on Windows and Windows Phone. So I'm going to do a demo of that now using a different app. And I'm going to start on my phone. And I'm going to run this demo app. And this is a demo app I wrote, and we'll see some of the code in a minute. And this is basically just a simple question and answer app. I ask a question, the other person answers it. I tell them if they got it right. So it's a very, very simple app. But you see here, this is my phone, Peter's phone, and I'm going to say, start game. And now I can either wait for people to try and connect to me because I'm browsing for them, or I can tap just like I did with the Nokia Cinematograph. And for this first demo, I'm going to tap. So I'm going to switch back to Sean's phone. And again, nothing's running. Tap the two phones together. It says somebody wants to play proximity demo. I'll say OK. And now he's waiting for the game to start. So just like that, got a connected socket, didn't do anything really, nothing messy, just got the connected socket. So if I switch back to my phone, I'm going to ask him, sir, can you just give me a simple question, please? Anyone shout out a simple question? OK, how's it going? How's it going? I hit send. If we look back at Sean's, he has a question, and the answer is, let's say, great. Where's a really happy face with sunglasses? OK. He says it's great. I get his answer great, and I'll say that's correct. All right, so because he is going great. And now on his phone, he sees the word correct. All right, so very, very simple game, but I connected the two devices without doing any particular work. Now I want to show you about how to do it using the browsing, and I'll get to the code in a second, but just to show you the two experiences. So now what I want to do is, I have some plants in the audience who have this app. If you can please come close to the front so you're within Bluetooth range, I'm going to show you the browsing experience. So now I have to juggle even more phones. OK. So what we're going to do is run the app on this phone and run the app on this phone. And if Nora and Sean, you can please run the app. And if you can please both press look for game. So what they're going to do is they're going to pretend to be clients looking for games. And if I go back to my phone here, I'm going to press start. And I see a bunch of different phones here. I see Bill G. I don't think he's here. I see Nora. I see Demo. And presumably I'll get Sean's in a second. But now I get to pick all the people that are around me which one I want to play with. So let's say I want to play with Nora. I click Go. Now, Nora, you should be able to see my name. And if you click me and then click Go, OK, and I can say, hi, Nora. It's not really a question. And you can say something else. Quickly. Hi, Peter. Yay, correct. OK, so that was an example of me looking for peers around me finding the one that I want to connect to, and then going ahead and connecting and starting a game with them. So let's go ahead and look at some of the code for that. Thank you, Nora and Sean. Yes, Bluetooth. So let's get out of there, back to Visual Studio. And I want to start, number 6. I want to start by just giving you a simple overview of how the app works, because that will help explain the code a little bit better. So in this particular app, there was the main page, which is the main UI, and it talks to 3 different view models. There's the lobby, which is where I initiated tap to play, or where I initiated the listing of the devices. There's the asker view model, which was the person asking the question. And there is the answerer view model, which is the person answering the question. Excuse me. And asker and answerer don't know anything about proximity, don't know anything about sockets. They just talk to this remote player object, which handles the abstraction of the sockets. And the lobby, which is the thing that does all of the, the connecting and so on, talks to a peer-to-peer manager, which is a wrapper around our proximity APIs. And it does some abstractions as well using this connected socket info, and it does things like surface up the items to put in the list box and handles negotiation of when to do NFC tapping and when to do looking for peers and so on and so forth. So we'll look at some of the code, but this is generally how the app is structured. And the interesting code is really in Peer-to-Peer Manager. So if we go to Peer-to-Peer Manager and we look at the Peer-to-Peer Manager object, it has some events that it uses to drive the UI. But the important API is really, if we start here with start host. And this is what happens when the host, the one that's hosting the game, wants to start something. So it calls start peer finder, and we'll drill into these in a second. Once it's started the peer finder, it waits for someone to do a tap and play, right? Because I might want to initiate one of these tap and plays. And then it also starts looking for peers. Because it's the host, it's going to be in that browsing mode as well. Because the way I wrote this app, I can do tap and play, or I can do browsing. Right? Your app, you might only support browsing, or you might only support tap and play. It's up to you. I support both. So that's what the host does. The client basically does the first 2 things. Right? It starts the peer finder, and it waits for someone to tap on it. But it doesn't have to look for peers, because it's not the one doing the browsing. Again, in your apps, you might have all your phones browsing all the time, and you might do a more complicated way of setting up games. But for me, it was easier just to have one host and one client. So what does Start Peer Finder do? Start Peer Finder basically creates a task completion source. And if you're not familiar with how tasks work, you can think of this as a named event. It's something that another piece of code is going to wait on to get signaled. And when it's signaled, something will happen. So it creates one of these task completion sources. It listens for a connection requested event, if asked for. It registers for the triggered connection state changed event. And this is the magic I mentioned that happens during a tap and play scenario. The magic is called triggered connection change. And we'll look at this event handler in a second. And then finally, it calls start. And as the comment says here, this is very important that you call start after you've hooked up these events. Because if you do it in the other way, the events have already happened before you start the peer finder. So hook the events and then call start. Okay, so that's what start peer finder does. Now this is the magic. So when triggered connection state changed gets raised when you do a tap and play type scenario. And the phones go through a sequence of phases during a tap and play. Right. First of all, they know that each other is there. Then they start negotiating who's going to be listening and who's going to be connecting. And then they kind of get a connection ready and so on and so forth. All that happens magically. You don't have to do any work. It just happens. But for the sake of building a nice UI, you might want to listen to some of these events. So when I get a peer found state, this event gets raised. It said it's found a peer. I'm just going to update the UI and say, peers found. You can move your phones away if you want to. If the state is connecting, again, I just change the UI state so my UI can say, hey, I'm almost there. And then if it's any other state other than completed, I don't care. So there are a few other times you'll get this event raised to help you build your UI if you want to, but I don't really care. All I care about now is completed. And if I got a completed event, that means that I have a connected socket, right? So this is the magic. Tap 2 phones, the completed event gets raised, and it hands you a socket completed, right? So you don't need to do anything. You don't need to know about Bluetooth. You don't need to know about NFC. Magic happens. You get a socket. And what it's doing with that socket is it's setting the result on this task completion source. And as I said before, if you're not familiar with the task model in .NET, the task completion source is like a named event. So basically, it's signaling this event saying, hey, I'm done, and here's the socket. And someone else, this wait for tap and play, is waiting on that particular event. So wait for tap and play, which remember both the host and the client listen for or call, just awaits that task completion source. So it's waiting for the event to be signaled. Once it's signaled, it goes ahead and raises its own event. And this is what the lobby is listening for. The lobby is listening for, when I finally got a socket from somebody, now I'll go ahead and I'll switch to being either the asker or the answerer, and we can go ahead and start playing the game. So wait for tap and play is really just waiting for this event to be signaled. And then finally, the method that the host calls, which is look for peers, essentially continues to call this find all peers async method, running in a loop, finding all the peers that are out there, displaying them in that list box, checking it again, displaying in the list box, etc. So it just keeps running, finding the peers that are available, and raising an event for everyone that it finds so that I can update my UI. And that's all it really does. So that's the basics of how both the host and the client work. Right? For tap and play, they use this triggered connection state changed event, wait for the completed event, magically have a socket. If you're using the browsing, the host calls find all peers async continuously until someone picks a peer. And then what happens is, finally, there'll be a connection requested received. It just, again, raises another event to the UI that says, hey, I finally found the peer, go ahead and start. So very, very easy to do both the browsing-based and the tapping-based support. But again, you can choose to do one or the other or both. Now, once you've got the socket, how do you talk on it? It's very, like I said, it's the same as doing the basic web server. So if we look at the remote player, this is the object that handles the sending of the messages and the questions and answers back and forth. It has a bunch of methods, wait for question, send question, etc. But they all basically end up calling two methods, send string async and wait for string async. These, in turn, call some helper methods that I'll walk you through in a second, send length prefixed string and receive length prefixed string. And these are just extension methods on the socket that help you send strings safely back and forward. And it's very important that you send strings safely, and I'll show you in a second why that's important. And that reminds me, I need to configure this phone to debug it. Right now it's configured to do the video out, and I need to configure it for debugging, which requires me to reboot, which I will do while I'm talking. So it does those two things. And the only other interesting thing about the remote player is when I want to create one for a socket, this is something that, again, you'll have to do some equivalent of in your applications. When the two devices talk to each other, they have to figure out who's asking the questions and who's answering the questions. And in the UI, one person is supposed to hit start game and one person is supposed to hit join game. But if they didn't, so let's say both people tried to start or both people tried to join, and the app was written such that they might start communicating with each other, you'd have a problem because they'd both be trying to talk past each other. And so what this remote player does is essentially creates a reader and a writer, just like we did with the basic web server, sets some encoding on it, and then it decides there's these two magic numbers, magic askerer and magic answerer number. And depending on if it thinks it's the asker or the host or the client, it'll either send the asker and hope to receive the answerer, or it'll send the answerer and hope to receive the asker. Right? So it's a very, very, very simple protocol negotiation to say who's going first. Right? So it sends that int over the writer, tries to read the int over the reader, and when all of them are done, it just makes sure that it read the right one and says, returns the right player. But if there are two people trying to be the asker or two people trying to be the answerer, it'll fail. Right? So you need to do something similar to this as well in most of your apps if you're trying to do these socket-based or proximity-based apps. Figure out who's in control. OK, now my phone is rebooted. So now I told you I was going to show you why it's very important to use these particular length prefix string APIs. And the reason is that not all, as you might know, not all characters are 1 byte in UTF-8, or even 2 bytes in UTF-16. And so you need to be very careful about how you count the lengths of strings that you're going to be sending and receiving over these sockets. So if I go to my extensions, and let's just make sure that I have, yes, I have a breakpoint there, and I have a breakpoint there. Good. OK, so what I'm going to do is I'm going to run the app again. And this time, I'm not going to show you on the screen because I can't debug and show you the screen at the same time. But I'm just going to, you've all seen the app. The app is going to run on here. And I'm going to start a game. And I'm going to join with this one here. And the first thing I'm going to do is I'm going to just write the word pizza, because everybody likes pizza. And I'm going to include, well, I'll put a hamburger. I thought I had a pizza, but I have a hamburger. If you look at the emoticon keyboard on Windows Phone 8, you have all these little pretty emoticons. I'm putting in a hamburger sign. I should have written hamburger. And hit send. And now we should break into our code here. Right, now I wrote the word pizza with a hamburger, right? P-I-Z-Z-A, hamburger, right? So you'd think there'd be 6 things in this string, right? But if I measure the string, the size in bytes, I don't know if you can see that, is 9. We might have a better view down here. So if we look down here, the size in bytes is 9, right? So P-I-Z-Z-A, hamburger, right? 6 characters, if you will, 9 bytes. And this is UTF-8. How did I get 9 bytes out of 6 characters? And if I look at the length of the string, right, this is the value that string.length gives me in, sorry, this has got messy. If I look at the value that string.length gives me, it's 7. Right? Again, I had 6, right? Pizza icon. But it says that the string is 7 characters long. And the reason is, and you can see the string right here. Right? The string here is pizza. The reason is that that little character is an extended Unicode code point. So it doesn't take 1 byte or 2 bytes. It takes 4 bytes to encode that particular character. Whether you're UTF-8 or UTF-16, it takes 4 bytes. So if we look at the array of that string, let's try and zoom in again. Right, here we have P-I-Z-Z-A, and then these 4 bytes here are all for that little hamburger sign. Right? So if you thought you had to send 6 bytes over the wire, you're wrong. If you thought you had to send 8 bytes over the wire, you're wrong. Right? You had to send 9 bytes over the wire. And the string you're expecting is actually 7 characters long, not 6, not 9, not 8, 7. Right? So that's why it's important to use some of these APIs, like the measure string API, and an API like this that, first of all, writes how many bytes it's going to, the receiver has to read. It has to read all 9 bytes. Then it's going to write how long the string is in code units, which is 7. And then it's going to write the string. And now we are going to wait for the other guy to send something back. And I think he's fallen asleep. Let's just see if I can write foo and some chicken. For some reason, this breakpoint didn't hit. But essentially, when the other guy sent back his text, you would have seen the same thing. I get a size in bytes back. and then a length in code units, and I need to use both of those bits of data in order to successfully read and write strings. And so reading and writing strings is not super straightforward when you're dealing with sockets directly. But that's basically it for the proximity, and then let's go back to the slides. And like I mentioned, no need to use NuGet for any of that. All these APIs are built into the phone. So sockets and proximity are all part of the phone itself. So then I wanted to spend a few minutes just talking about some tips and tricks that we have on using networking on Windows Phone. So some tips from today, very, very briefly. Remember to set up your dev machine correctly. And you need to do this for each new project, because that will listen on a new port. And if you move your laptop from network to network and it gets a new IP address, you need to do it every time you get a new IP address as well. Excuse me. Use the pre-release version of Web API Client Library. So remember, for the HTTP Web API client, you have to choose pre-release. If you choose the non-pre-release, you'll get some errors from NuGet that it can't install. So use the pre-release ones. We talked a bit about proximity and how you have these two different models and figure out which one you need to do before you start writing code. If you write the code first, like I did when I first did this demo, you get very confused, right? You need to figure out what you're supposed to do. And then hook up PeerFinder before calling start. Another couple from a bit early on is if you want to put HTML into the web browser control, remove those meta tags, otherwise you will get raw HTML. And for the networking stuff, for the native networking, I just copied the code straight out of an SDK sample. I didn't modify it at all, it just worked. And then finally, the top tip from me is always use Comic Sans MS, because it's everyone's favorite font. So an app I want to talk about briefly is FeedReader. And FeedReader is an app in the store, and it comes from a guy called Sam Jarrowan. He actually literally sits next to me at Microsoft, and he wrote it for Windows and Windows Phone. And so I asked him what some of his tips were for people that might be doing the same thing, right? Writing an app that works on Windows and Windows Phone. And basically, he said a lot of things, but some of the most interesting things were, he said, he uses HTTP web request because he started his project back on Windows Phone 7. And like I said earlier in that big chart of all the APIs we support, we continue to support that API so that your code continues to work. But if he was starting fresh, just like I suggested to you earlier, he would start with HTTP client because it's so much easier to use, and the async programming model is so much easier. Now, also in his time being on Windows Phone, and then Windows Phone 8, and so on and so forth, he's switched between using JSON.NET and the built-in data contract JSON serializer several times. And he settled on JSON.NET because he says it's basically just better, and it's faster. And even our HTTP web APIs, the stuff I showed you earlier where I was serializing those phone objects back and forth, that's using JSON.NET as well. Right? So use JSON.NET over the built-in serializer. And then finally, I want to show you the app briefly. He had a good comment around some UX decisions that he made about when to use the browser control and when to build UI himself. Because as an RSS reader, it shows RSS. And you might think, well, you should show your RSS feeds in a web browser control. And I'm not showing. This is set for debugging. It's not set for viewing. So unfortunately, I can't actually show you this. My bad. But what he has here is, I don't know if, I'll have to describe it. What he has here is, when you browse through items, he has two modes. He has a mode where he actually takes the HTML, strips out all of the tags to just get the plain text, and then shows you the plain text in a manner that's very easy to navigate on the phone. It's in a pivot, so you can slide across Article 1, Article 2, Article 3, etc. And so that's a really good way to do very quick browsing. And that one uses XAML. Right? He took the HTML, stripped out the formatting, put in the text, very quick browsing experience. But of course, it doesn't have the full richness. It doesn't have all the formatting. It doesn't have the links. It doesn't have all the images. And so if you want to, you can tap a button, and you can get into the full HTML view where you get all of the goodness of the HTML. So he had some good feedback and some good suggestions around when you're building these types of apps, think about when it makes sense to do a web experience and when it makes sense to do a first-class platform experience. So another thing I wanted to show you, and I need to reboot this, which should be quite quick. Another thing I wanted to talk to you about was Engadget. And hopefully I can reboot this while I talk about Engadget. So what they've done is, they're also basically an RSS reader. But what they've done is they use background agents to preload data, meaning that when I'm not using their app, it's still doing work for me, getting things from the network, downloading to the phone. They do this for a couple of things. They do it to update their live tile, so it can show you the latest picture on the tile and how many articles you haven't read. And they can also do that to download the articles themselves. And what this means is that if you get up in the morning, you run on a plane, those articles will be there even though you don't have a network connection on the plane. And it's also kind of just in general a good UI that they have rather than being a pure browser-based app, because they have some nice ways of doing things there. And I'm just rebooting, so let me put this on, and I should be able to show you Engadget. Six. Allow. OK, so you see Engadget is flipping here, and it says Nokia will pay you up to $300. Oh, OK. And it says there's a 14 there, which means there are 14 unread messages. And I haven't opened the Engadget app for a while. I accidentally tapped on it last night, but I quit it before it ran. So in theory, I haven't run this app for days. And what I'm going to do is I'm going to go to Settings, and I'm going to turn on aeroplane mode. Notice I say aeroplane because I'm Australian. Turn on aeroplane mode, and that should make sure that I have no network connection. OK, no network connection. If I go back and I click on Engadget, it'll tell me that it doesn't have a network connection, but it should still have content available. So it says no internet connection is available. But if I scroll across the latest apps, the latest one it has is from 11:30 a.m., which I guess is not Pacific time. But you see that it has some articles from today. And I haven't run this app at all today. Right? So it used the background agents, something I'm not talking about, but you can find on previous builds, sessions from previous build. It used a background agent to download network data without me having to run the app. Right? So that's another cool thing you can do with networking is preload content, because then the perceived performance of your app is faster because I'm not waiting for things to download. And now if I look how quickly I can flip through all these articles, right? Very, very fast. And of course, it doesn't have the images because I have no networking. But you notice that it had preloaded some of them, right? But very, very snappy interface because that content is pre-downloaded. So that was something that I thought was pretty cool from Engadget. And then finally, just some tips from other popular apps. Priority queues can be important. If you have an app that is doing a lot of different things, downloading lots of images, and then the user switches away to a different page, and they download some more images, and then you download some text, and so on and so forth, and you just blindly throw out all these requests and wait for them to come back, you can end up in a situation where the networking stack is busy doing work for content the user doesn't care about anymore. And so one of the bits of feedback we got from some internal Microsoft folks was, if you have that kind of situation, consider building a priority queue so that you queue up all your requests, and then if the user switches to a different experience or you decide you need to download something else, you can dump all the ones you haven't already loaded and start loading a new one. And so that's an interesting tip there. I've showed you the HTTP client libraries from NuGet, but there's now, I think, a pre-release version of compression as well, so you can now do compressed data over the wire, which is very important for mobile devices, of course. Saves bandwidth, saves battery. Interesting one here is that if you generate URIs dynamically, right, you're building them up based on content in your app, sometimes they get too long, right? And if they get too long, longer than the network stack or the proxies or whatever can handle, you might end up with obscure bugs in your application. And one particular guy told me they got stuck for quite a while trying to figure out why the app was broken, because nothing seemed broken in the app. Excuse me. And the reason was that the URLs were just too long. And so a good tip here is if you are dynamically generating URLs, make sure they're not too long before you send them. And then finally, something I didn't show you today, but is a cool tool we have in Visual Studio, is the network simulator. So when you're using networking with the emulator, you can pretend that the network's gone down, or that it's a really slow network, or that it's dropping packets. And that really helps you test your app in different situations. And so that's basically it. So what do we do for the agenda? We talked about HTTP client and XML HTTP request for native code. We talked about WinRT sockets, and we showed some web browser code and some proximity code. We talked about proximity and how you can use the peer finder and sockets to write a simple game. And we had some tips and tricks around using Comic Sans MS and some other fun stuff like that. So other resources, if you want to know more about the peer finder and how you can do things like talking from a phone to a device, not just a phone to another phone, Tim Laverty is going to give a demo, I think, of the Sphero later today. And he also gave a version of this talk last year at Build where he made a Lego Mindstorm robot run. So he has a couple of talks, one you can go to today, one you can view online. Sean McKenna in the back of the room will be talking about app-to-app communication, and he'll talk a little bit about NFC there later today. And then another thing that people commonly do with networking is mapping type stuff, so show maps or do reverse geocoding and so on. Mike O'Malley is talking about that in this room later today. And then there are a few other ones that have already passed that you might want to look at. Matt Hidiger's talk on building for both Windows and Windows Phone. So I showed you a little bit about how a web client can share the same code. He talks a lot more about that. Azure is obviously a big thing. There's a talk about phone in Azure. And then Peter Smith is talking about the WinRT HTTP client right now as well in a different room, so you can watch his online. So please fill out evaluations. This is the way that we learn how we can get better, how what we can do to make this more valuable to you guys and girls. So please fill out the evaluation form. You should be able to scan this now. And I have a phone to give away for everyone that stayed. It's a Nokia DevKit phone. And I need to ask you a question. And so the question I want to, and whoever I see put up their hand first wins, very unscientific. No, you can't put your hand up before I ask the question. And so the question I want to ask is, how many bites are in a hamburger? I think it was you, sir. 4, yes, that's the right answer, yes. So if you can come up and give me your business card or an email address, I can give you a phone. So that's it. I'll leave this up so you can scan it if you need to. And that's it. If you have questions, I can answer them now or outside later on, but thank you for coming.